Welcome students for the fourth session of heat transfer on force convection. Today I am going to take the fourth numerical on the force convection part. Again I am going to read the numerical over here. Air at 30 degrees Celsius is flowing across a tube with a velocity of 25 meter per second. The tube would be either a square with a side of 5 cm or a circular cylinder of diameter 5 cm. Compare the rate of heat transfer in each case if the tube surface temperature is maintained at 124 degrees Celsius. Okay guys, this is what a numerical it is. Very simple numerical guys. But here the one thing we need to remember here it is, means we need to be careful in this numerical is that he has given both the plate when it is a square as well as when it is a circular. Okay, we need to calculate in both the cases what is the heat transfer, and also we need to compare in both the cases. Okay, we need to tell it that in which case the rate of heat transfer is more. Okay, if I see the given data, what he has given T infinity which is 30 degrees Celsius, and he has given velocity which is 25 meter per second, and he has given both the diameter, nothing but for circular pipe its diameter is 5 cm, nothing but 0.05 meter, and he has given for a square plate a side it is as a 5 cm. Okay, and also he has given TW that is 124 degree Celsius. So as you know already guys, we need to calculate first mean temperature in order to take the properties of the air. So we know how to calculate the mean temperature, that is TW plus T infinity divided by 2, nothing but 124 plus 30 divided by 2, nothing but we got 77 degrees Celsius. So from data handbook, at air at 77 degrees Celsius we need to take down the property, nothing but viscosity, Prandtl number and thermoconductivity. Okay, once you got these values, your next work is to calculate the Reynolds number. Okay students, here we need to calculate Reynolds number. Here we are taking VD by viscosity, but previous problems we have used VL by viscosity. Either you can use a diameter or length, because in dimension analysis both carries the same property. The D indicates the geometric as well as L also indicates the geometric property. So you can use VDL by viscosity or VL by viscosity. Here since the diameter is given, I am using VD by viscosity, that is kinematic viscosity. Okay, that is 25 into 0.05 divided by 20.92 in 10 raised to minus 6, which we have got from the properties of air. So we got overall Reynolds number is 59.75 into 10 raised to 3. Okay, so we need to take down first case. The case one is what? We need to calculate the heat transfer for circular tube of diameter 5 cm. Right? For that, from the data handbook, you just copy the equation. The equation says that Nusselt number is equal to C into R raised to M P R raised to 0.0333, or some book may give C well directly it as 0.0266. Okay, you just check it out with your data handbook. If you have direct equation, no problem. If it doesn't have direct equation, he might give some C value. You just cross check with that one guys. And here the Reynolds number what we are having it is, that is 59.75 into 10 raised to minus 3, as well as the value of M is also given in your data handbook. The C and M value they have given depend upon your Reynolds number value. So once you cross check with your Reynolds number what you got there, within that range your C as well as M value will be considered. Okay, by taking out these two from the data handbook, you can substitute those values in the equation, main equation, so that you can get the Nusselt number as a 167.78. Okay students, once you got 167.78, using the Nusselt equation number, that is Nu is equal to HL by K or HD by K. Since here we got a circular diameter D, so I am using HD by K. Here the value of D it is 0.05, and K value which has taken from properties of the air, that is 3 into 10 raised to minus 2. 1 second guys, right, minus 2. So here the Nusselt value is 167.78. So we got H value by substituting all this equation. We got H value as a 100.6 watt per meter square. Once you got H value guys, already we know that Q is equal to HAS into TW minus T infinity. Here the area is not B into L in this case. Now it is, since it is circular, that is pi into d, nothing but circumference into L. So how it take place, guys? If you consider this as a circular tube, right? So the pi into d indicates the circumference of a circle and L indicates its total length. So which gives the area of the cylinder, nothing but I can say circular tube. So if you're going to consider this one, that nothing but we're going to take area as a pi d into L. So if I substitute those value over here, we get the value of TW as 124, T infinity as 30. So we get Q as a 148.54 watt. So this is what the first part of the problem. Now moving to the second part of the problem, guys, where he has given for a square tube. In spite of now I'm taking the circular tube, I'm going for square tube. Okay, so guys, square tube, nothing but you need to assume all sides are a square. Okay, so we need to go for square tube, guys. So again, from data handbook, for non-circular shaped flow, means we need to note down the Nusselt number, that is 1.1 into C1 into RE raised to N, PR raised to 0.5. So guys, the value of C1 and N, so depend upon your RE what we got previously, that is Reynolds number. So Reynolds number what we got 59.75 10 raised to 3. For that the value of N it is 0.675 and C1 value is 0.092. Okay, substituting these values in this particular equation, we're going to get Nusselt number as a 151.717. Okay, so as we know that Nusselt number is nothing but HD by K, substituting those Nusselt number in this equation, we are going to calculate the value of H, nothing but 91.02 watt per meter square. Once you got the value of H, guys, again same thing, again we are going to substitute in a Q is equal to H AS into TW minus, but this time the area for square plate is going to change, guys. This is since it's a square plate, guys. So the area this time becomes 4 times of breadth into length. So this is, we are going to use it over here. So once you use the area as this one, guys, so we are going to get Q value as a 1713.5 watt. So we can say that if you see both the Q value, first Q value it was for circular 1485 watt per meter square, and here 1713.5 watt meter per square. So if I see the ratio nothing but is gives me 0.86, nothing but 0.86 times it has been increasing. So I can say that your square plate has a more heat transfer capacity compared to the circular plate. Okay, getting, guys? So this is what the fourth numerical of a force convection. If you have any doubt related to this numericals, you can ask me in the comment box. Thank you.